When you are doing curve sketching techniques and you are given the function, you need to do all the prepping up yourself. You have to find the domain, the x, the y-intercept, the first derivative, the second derivative, 5 intervals of increase, decrease, concavity, local extrema, and inflection points. Here, it's actually done for you. So you need to be able to read what's given to you, and now all you need to do is put it in a sketch, which as we know is sometimes easier said than done. So I'm going to set up a big graph. And I'm going to read the information. So my domain is all real numbers. Okay, I'm going to be defined everywhere. Perfect. The limit as x goes to positive and negative infinity of f of x is equal to 2. Well, that is the definition of a horizontal asymptote. So that means that I have a horizontal asymptote of y is equal to 2. And then I'm given 5 points. So let me put the points and the asymptote. So let's see. I need to at least go to 4. 1, 2, 3, 4. I'll go to 5 for good measure. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 3, 4, 5. Okay, I'm going to put my asymptote first. I'll do it in red. And I know that as x goes to negative or positive infinity, my y's are going to get closer to 2. So either, for example, it's going to come up from the bottom like this, or it's going to come up from the top. And I'm not exactly sure which one it's going to be yet, and the other information will tell that to me. Let's erase that for now, and let's plot the points. So let's see, I have negative 4, 0, puts me right here. I have negative 2, 0, 0, 2, negative 2, and 4, 0. Okay, now I'm going to label these points and figure out if I have any local extrema or any points of inflection. So again, my domain is all real numbers, so any point can be a local extrema or an inflection point depending on what the sign charts are telling me. So it will be a local extrema if I go from decreasing to increasing or increasing to decreasing. So let's see what my first derivative sign chart is telling me. So on the left of negative 2, I'm decreasing. And then I'm increasing on the right. That will make negative 2 a minimum. So I'll label that because I know I'll hit a min there. At 0, on the right, I am increasing, and on the left, I'm decreasing. That will make 0 a max. And at 2, on the left, I'm decreasing. On the right, I'm increasing, which will make 2 a min. Okay, so I know I have to change direction when I get to the min and the max. Then let me take a look at my second derivative. So I will have inflection points and I'm changing the concavity at negative 4 and at 4. And again, every number is part of the domain, so anywhere it changes concavity is a point of inflection. So this will be a POI, or IP for inflection points, whatever helps you label. And then I need to take a look at how I'm starting. So everything up to until I hit my minimum, I'm going to be decreasing. And as long as I know how I'm starting, then when I hit my mins or my max, I will change direction. And then at before negative 4, I'm concave down. And then anywhere I hit a point of inflection, I'm going to change my concavity. So I'm going to be decreasing and concave down, and I got to get closer to my asymptote. So I'll draw it right to left because it's a little easier for me. But this is decreasing and concave down. Now I need to change concavity. So I will decrease and concave up. So here's my point of inflection. I hit my minimum, so I got to go back up, but still concave up to my max. I hit my max, and what's important here is that you don't change concavity, right? This is not a point of inflection. So I stay concave up, but I decrease back to my min. I hit my min, I go up to my point of inflection. I hit my point of inflection, and now I concave down and increase. And here is my final graph. Let's do one more. Okay, so now I have domain all reals except at negative 2. So either -2 will be a hole or an asymptote. So let's take a look at what's going to happen here. So I have the limit as x approaches -2 from the left is equal to infinity. And then as it approaches -2 from the right, it's -infinity. So that's going to be a vertical asymptote. I'm going to have a vertical asymptote and x is equal to -2. And the limit as x goes to infinity of f of x is 1, means that's a horizontal asymptote, but only on the right side. It doesn't say it approaches 1 as -infinity. It's only approaching 1 on the infinity side. And then I have some points. So let's plot everything. Let's put our asymptotes. So let's see what we got. So let me see. So 1, 2, 3, 4, 5, 6. I see I at least need to go to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. How do I know how many tabs I need to do? I just look at the points and where I need to go to. So I have -4, 0. I have 0, 0. I have 4, 3. 1, 2, 3. That puts me up here. That might be a max. It's a little high. So we'll see that. And 6, 2. Don't want to assume yet. My sign chart will tell me. Then I have a vertical asymptote at -2. X is equal to -2. I should specify. It's an equation. And y is equal to 1. But the asymptote will only affect the right side of the graph. It will not affect the left side. So here we go. Let me read my sign chart and figure out if I have any minimums or maximums. So I can see that on the right side of 4, I am increasing, and on the left side, I am decreasing. So I will have a max. See, I could tell it was a little high. -2 is neither a min or a max for 2 reasons. The main reason is that it's not part of the domain. But even if it was, the sign doesn't change. Then I look if I have any point of inflection. So what's important to notice is that, yes, you are changing concavity at -2, but it's not part of the domain. So it cannot be a point of inflection. However, 6 is part of the domain, and the concavity changes. So this will be a point of inflection. And actually, I see that this is a little low, because I need to have 6, 2, so I'll bring it up a little bit. Okay, so let's take a look at what we have on the up to -2. So up to -2, I am told that I am decreasing. Oh, I am not told. I am increasing. It's positive. I am increasing. And I am concave up. Okay, to be increasing and concave up, I'm going to look like this. And then I need to continue, and I know that as x approaches -2 from the left, I'm going to positive infinity. Look at this. It told me that I was going up, so your graph needs to be going up. Sometimes one of the misconceptions is, ooh, but you're crossing the horizontal asymptotes. That's okay. Horizontal asymptotes can be crossed, but verticals cannot because they're never part of the domain. Okay, after -2, from -2 to 0, I'm still going to be increasing, but now I'm actually going to be concave down, and I'm going to be concave down all the way up to 6, all the way up until my inflection point. So I am increasing. I hit 0, 0. I go to my max. I'm still concave down. Once I hit my max, I need to start decreasing. I hit my point of inflection, and I change to concave up. And as I know, my y's will get closer and closer to my horizontal asymptotes. So I'm actually increasing all the way to my max, not just to 0. And then once I hit my max, I start decreasing. And once I hit my point of inflection, I'm concave up. And here's my final graph. You can check one more time. Am I increasing, decreasing properly? I hit my max. I change my inflection at my point of inflection. I change my concavity at my point of inflection. Everything looks good. I am finished.